So in today's session, we will cover what is data modeling and what is relationship, how to define or create relationship between tables. And before all these things, we will see why we need to create data modeling in Power BI and also why we need to create a relationship, all those things. Okay. And previously you learned how to connect to different data sets using Power BI. We have seen how to connect to flat files such as comma separated value files and how to connect to database, how to connect to SQL server. Likewise, we have seen how to connect to different types of the data sets using Power BI. Now we will see what exactly data model and why we need it. And then let's see how to create relationship between the tables in today's session. Okay. So what is a data model? So what is a data model, first of all? Okay, creating a great data model is one of the important tasks a data analyst can perform in Microsoft Power BI. Okay, the data model can be compared to a roadmap or an architect's blueprint. So before you build a house, you need to have a solid blueprint in place. Without having the solid blueprint in place, if you start build the house, what will happen? Later point in time, if you realize, right, you forgot to keep some provision in your kitchen or in your living room. For example, in your living room, you want to keep a tap, right, and also want to keep a wash basin, and also you want to keep additional tap in your kitchen. Later point in time, if you after constructing the house, if you realize it, what will happen? You need to end up breaking your walls. Breaking the walls involves cost, and again it requires time, right? It will take 5 days or 10 days to breaking the wall and putting the new taps there, right? It takes time, and also it can damage other thing also, right? So for example, if you live in an apartment, your wall is common between the two houses or three houses. In that case, if you break the wall, you need to get permission from them. So it requires a lot of effort and time. After you construct the house, if you plan to make a change, right, to your house. Similarly, once you develop your application and then later if you realize you want to make some changes to your data or tables, right, so it will cause some problem. So that is the reason why try to create a scalable robust data model before you build any applications or any website. For example, you want to develop a e-commerce website, or you want to launch a Swiggy like app. So make sure that before you build all the things, your data model, right, or in you have a solid data model strategy in place. Okay. So okay, now the question is, what are the benefits of having a data model in place? Your data exploration is faster. For example, if you want to query the data, it will be much faster. Okay, the output will be displayed in a much faster way. For example, you wanted to view so the sales by category, by region, by quarter or years or month. So in that case, what will happen is it will take a lot of time to fetch the data if you don't have the proper data model in place. Okay, one of the reasons for slower reporting performance is not having the proper data model in place. Okay, so hence the data exploration is faster if you have the solid data model in place, and then the aggregations are simpler to build, and the reports are more accurate. This is very, very important. Reports are more accurate. I'll show you in Power BI, right? So without data model, what is going to happen? Okay. And writing reports takes lesser time. Reports are easier to maintain in the future. Okay. Okay, so providing set rules for what makes a data model is difficult because all data is different and the usage of data varies. Generally, a smaller data model is better because it will perform faster and will be simpler to use. Anyhow, we will take a look at all these things a little later. And first of all, you need to understand the different types of data model. Once you get into a project, let's say you join with a software company, you join with Accenture or any other IT service based companies, or you join with any product based company. Before we develop the report, right, so we need to do the requirements gathering. You need to know the software development life cycle. As part of the software development life cycle, the first phase of the software development requirements gathering. So you need to conduct a workshop with the various line of business managers within your organization. For example, you have supply chain department. Usually we call department as a line of business in US, right? The Americans, they say that way. So you have a supply chain line of business. For example, supply chain. There's something called supply chain. Let's say yours is a manufacturing or it's a e-commerce company. You have a supply chain line of business. This is a department, and you have something else called category planning. Category planning, and you have something called finance department. Finance department is common for all the sectors. You take any sector or any company, finance department will be there, and then you have something called payroll. Right, likewise, different departments are there in a company, line of businesses are there. So what you do as a data analyst, along with the business analyst and other lead data architects, you will conduct a workshop with the key stakeholders that belong to each department. Okay, for example, the CEO of the company, right? So they are the sponsors, and they wants to say, hey, we wanted to develop some reports and dashboards around supply chain. For our supply chain line of business, we need to create some reports and dashboards. And what we do is usually along with the business analyst and the architects, as a data analyst, you will be conducting workshop with all the key stakeholders that are part of the supply chain. You just don't go and create one or two reports. Okay, what we do is you just find out, do they have the reporting environment already in place? If they say no, then it is a good opportunity that you can develop more number of reports for each department. So what we do is instead of going and creating one or two reports based on the requirements of one or two people in the supply chain department, you call everyone, all the key stakeholders in a single call, put everything in the single call, and conduct a workshop, and then ask them what kind of pain they are undergoing and what are the key business questions that needs to be answered. As part of this workshop, you get all these things, what are the key business questions they want to answer it, and what kind of reports that they need it, how many, so what, which people in the department, the same report needs to be shared. All this information, you will gather it as part of the workshop. Once you understand the holistically all the reporting requirements, then what you do is you start to do the concepts. As part of the requirements gathering itself, we come up with something called conceptual data model. In the case of software development lifecycle, as part of the requirements, at the end of the requirements gathering, we come up with the conceptual data model. So this is basically an abstract model, right? It's a preliminary step wherein we define what are the tables that the database should contain at a high level. Okay, at a high level. Let's say in the case of grocery business, okay, it needs to represent a data model. For example, the customer places an order. Customer places an order, and the products appears on orders, and finally, there is some, the products falls under different categories. So when you talk to the key stakeholders during the workshop, you get to know about their business, right? In the business, what entities do they really need it? To capture all the customers' information, they need to have a separate table called customers to capture all the products that they sell it in their retail chain, right? Or the retail store. You need to capture all the products here. Similarly, make sure that the products that which all products belong to which categories. In order to capture that, you need to have a separate table wherein you need to capture the categories. So this is what we define it as part of the conceptual data model when we have a discussion with the key stakeholders during the or at the end of the or during the requirements gathering phase. Okay, that is the first phase of the software development lifecycle. Right, so we gather all these high level information, and then what we do is we start define and we'll find out how these entities are interacting with each other. Like I said, the customers are the one placing the order. The customer may place zero or more than one order, right? So more than one order. Whatever the orders placed by the customers, that will be captured here. this orders table will capture all the events in it. Okay, for example, a single customer can order 0, right? So they then all not necessarily, let's say my customer base is 1 million, or for simplicity's sake, I just take 10,000 customers are there. Just because I have 10,000 customers, not necessarily all the customers have to order the products with me on a daily basis. Some customers, they order it. Some customers, and some days they don't order it. So that's the reason why 0 I put it here. So 0 or customers order 0 orders or more than one order also. More than customer place 0 or more order. We can say that way. And then the order is placed by one or more customers. A single customer, may place 0 or more order, and at the same time, orders are placed by one or more customers also. Okay, so and also the products can appear on 0 or more products. Just because we sell 1 million products, not necessarily all the orders should capture all the products. There are some orders, you may not have, so some orders you will not have the same products. Some orders, let's say two persons, right? A, B, they ordered, they ordered the products, but their order numbers are different. But whatever the order, products that ordered by person A, the same product was ordered by person B. And there are situations like, whatever the product B ordered, he did not order. His products were completely different. The products ordered by this customer was completely different. Okay, so the products appear on 0 or more orders. So these are all the business facts that needs to be included as part of your conceptual data model. Okay. Next one is, who is responsible to create this conceptual data model? The business stakeholders and the data architects. So remember that data architects. There is a separate role called data architects. So they are the one paid very high salary. Okay, so even they are all high paid employees. The data architects, they have the domain knowledge also. For example, you are working in finance domain, or you are working in supply chain, or you are working in some other domain. Right? So they are basically a techno functional guy. So they know the domain as well as how to model the table. This is called your data model. Okay, concepts at the high level. While interacting with them, you understood customers place in order, and the products appear on the orders, and also they are customers ordering across different stores, and the products falls under different categories. Likewise, so these are the, now you understood with this how these tables are interacting with each other, right? So the product tables, the category tables captures, the products table, right? We capture which all products falls under which categories, and in which orders, which products ordered, and which store by which customers, right? So you will get to know if you have the table design like this, data model design like this. But you tell me one thing, if you keep all these things in a single table, what will happen? It will slow down the performance. First, for example, in the case of Citibank, the Asian customer base is 25 million customers are there. And let's take for example, even let's take the Amazon or all the leading e-commerce companies. If you see their customer base is too high, so many customers are there, maybe 1 billion customers. And if you see their products in their website, Amazon website itself, right, they listed 1 billion products in it. How many of you are aware of this one, right? So the volume of the data is very, very high, and every day, every 1 hour, on an average, the Walmart, the transaction, the total number of transactions on an average was 1 million every 1 hour. So the business operates across 24/7 across the globe, right? 24/7 across the globe. You just imagine, on an average, every 1 hour, 1 million transactions are raised by the customers across the globe. So in that case, 24/7 into 1M, how much, right? It's a huge volume of the data. And again, per day alone, you store huge volume of data, and every month we don't have to so if you think about the monthly volume of the data, it's too high, right? And on top, if you combine everything in a single table, what will happen is to perform any data analytics, right? You want to create some reports, you want to pull the data from this table, it'll take a lot of time. That is the reason why what they do is they keep the data logically in a separate table, and then they create the relationship between the tables. So we'll be doing it, the data architects, along with some business analyst, or some business stakeholders from the customer side, right? So we involve the key people, and data architect, he know the technique, okay, how to perform, he knows the subject, okay, he's the subject matter expertise when it comes to data model design, and he knows how to create a relationship and what kind of cardinality that you need to define it between the tables. He knows everything. Okay, now the question is, fine, we identified all the key entities. Entities are nothing but tables, or nothing but the tables. We identified the important tables that forms part of your retail chain, okay, or the grocery chain, okay. So now you identified all the important tables, and also you understood the relationship, how these tables are interacting with each other. Okay, fine. So now the question is, without creating a relationship between the tables, can I simply create a report? You can create a report, but it will not show the accurate result. It will not do the filtering across the tables just by itself. Okay. So in that case, what you need to do is you need to create the relationship between the tables. I will explain you how to create a relationship down the slide. Don't worry. Okay. Next one is the logical data model. It is an extension of our conceptual model. So the database architect, right, he moves on from the big picture. This is the big picture, right? So what tables are required, how these tables are interact with each other, and what is the volume of each tables on a daily basis, how many number of customers, new customers are captured, and how many orders raised on an average by each customer, what are the total number of products. Okay, all these information, volumetrics information. Volumetrics is the number of records in each table, daily basis, weekly basis. Right? So likewise, you capture all the information. But overall, as part of conceptual model, you get to know the big picture. So how many tables are required, and how these tables are interact with each other, and each table on an average, how many number of records it will have it. Fine. The next step is, as a data architect, he moves on from the big picture of the concept model to the logical data model. In the case of logical data model, we start look at the detailed structure of the database. For example, so knowing the entities, key entities that forms part of your the retail chain is not sufficient, the domain is not sufficient. You need to know what are the attributes. Attributes are nothing but columns, right? So in each table, what columns we need to capture it. So we add the attributes. Columns are also called as attributes. Attributes or columns. The reason why I use these different terms is you do not know during the status call, the Americans, right, or your customers, they'll use different terms. Hence, you should be familiar with this. Okay, in this, each table, we identify or add the attributes, and also we define the relationship, and we define the business rules. Okay, what do you mean by business rules? The customer entity have at least one unique identifier. For example, in the case of customer table, this is the unique identifier, primary key. This is called your primary key. Okay, it's something like your Aadhaar number. Aadhaar number is unique to each citizen. Similarly, each customer in this customer's table, they will maintain a unique key. The customer key will not be duplicated. Okay, each customer, it is unique. Okay, and similarly in the products table also, you will have something called product key, and you have something called product. This is the primary key using which we can uniquely identify a specific product. And also, as in each table, we will have the primary key column. So these are kind of a lookup tables. See, these are the lookup tables. In the case of data warehouse, instead of saying lookup table, so the customer table is a lookup table and products is also a lookup table. And except order fact, rest of them are all called as a lookup tables or dimension tables. Guys, please remember this term, dimension tables. Rest of them are called your dimension table. Okay. And okay, so the next thing is, in the case of a logical data model itself, we define the relationship. Okay, we define the relationship between the tables in addition to adding the columns to, adding all the columns that forms part of each and every table. We will be creating the relationship between the tables using some business rules, something. For example, like I said, the customer places order and products appear on orders, and finally there is a cardinality. There is a cardinality. What is cardinality? There is a relationship. For example, if you wanted to know in a specific order which customers order which products, to answer this question, obviously the data are stored in these three different tables. In order to retrieve the information from these three tables, you need to define a relationship. So this is where the relationship is fine. We are going to create a relationship, fine. But what exactly cardinality? Cardinality is nothing but the relationship, the degree of relationship, which means the customer places 0 or more order. There is a 0 to, right? So, or let's 1 to many or relationship. There is a 1 to many. Order is placed by one or more customers. Order is placed by one or more customers. In that case, right? Order is placed by one or more. So that's the reason this is a many side. This is one side. Order is placed by one or more customers, right? So one or more customers. This is many side. Okay, and so this is one side. Each customer can order a single order, or they can order more than one. They can place more than one order. But in the case of order fact, if you take a look at it, so the more than one customers, they order the product. Okay, so this is called one to many, and this is called one to many relationship, and this is called one to many relationship, and this is called one to many relationship. Okay, each product will fall under one category only. Okay, you cannot say a single product can fall under more than one category. We don't say that, right? So if that kind of situation arises, we will create another table called subcategories. Okay, in the subcategories, this one will be linked with the categories table. In that case, okay, the subcategories will be linked with the products table. So each table will be in each table will have it will capture all the attributes or columns that are required, right? For your reporting requirements, it will be captured here. And also we define the relationship, what kind of relationship. For example, the customer key and customer key in this table, customer key in this table, right? We will create a relationship between these two. So we create a relationship between the two tables based on the common key. We say that we also, right? So we can create a relationship between these two tables based on the common key. What is the common key between these two tables? Customer key. And product key, we create the relationship between, so let's say you have product key should be there here, and the product key and product key in this table and product key in this table are common between these two. Hence, you are going to create a link these two tables, with this relationship. I will show you in Power BI desktop. Okay, don't worry. First, understand the theory part. Okay, and next we will see the notation. As I said, right? So, a customer may order a product, or he can order a single thing, something like that. Okay, 0 or 1, 0 or 1. And there is so if you see this notation, right? So that means 0 or 1. Okay, 0, 1 or 0 or 1 order. And here, if you see here, 1 to 1, this is 1 to 1 relationship. Something like each employee, the employee's employee ID, right? Each employee's ID is unique. For example, company, and employee. The company can have, each employee can have only one employee ID. Okay, and a company, in a company, each employee, right, can have only one employee, right? Each company can have more than one employee, but each employee can have only one ID. So in this case, right, this is kind of one-to-one, and zero or many. The same thing, the customer and orders table. A customer may order, or they may not order, but the customer may place zero or more order. So zero or more. When you see the crow feet here, that means more star. They represent it star. Okay, and if you see something like this, one, there's a one or more, right? So each order should have a product in it. Without having a product, you cannot say it is an order, right? So one or more products will be there in an order, right? So your order can have more than one product, but it should have at least one product in it. So if you see this notation, one or more, zero or more, right? So here one-to-one relationship. Or let's say instead of saying company, or let's say company is correct, and CEO. A company can have only one CEO, right? Each company can have only one CEO. A CEO, only one CEO will be there in a company. This is in a classic example, one-to-one. Right, so 0 to 1 is something like in a marriage, right? A person, it can be a married guy, status, right? His marital status can be a single. Zero means unmarried, so one means married, right? Either a person can be unmarried, or he can be a married person, right? So zero, kind of one. This is one example. 1-to-1 is this one. A company can have only one CEO. Each company can have only one CEO, right? And here, a customer places zero or more orders, but yeah, order can have at least one product in it or more than one product in it. So you need to remember these things. But this has got nothing to do with the Power BI data model design. But this is the fundamental thing. This is the building block. You need to remember this. But usually the customers, they give the data model design also in some cases. Okay. So in that case, we need to, by looking at the data model, we need to create the relationship in Power BI desktop. Okay. So you need to remember this is pretty simple. Okay. So now the question is, okay, I'm a Power BI developer. Do I need to be aware of the data model design? All the thing? Yes. If you know data model design, right? If you are good in data model design, obviously you can, your salary will be more, and you can create visibility. For example, if they onboard you in a project, and if they see that you are good in data model design also, then they will think you are a most sought after person, right? So it's always good if you know multiple, if you have multiple skill sets, it's good. The next one is, after logical data model, we have something called physical data model. In the case of physical data model, what we do is, that is where we are going to create all the tables into a database. Okay, it is something similar to this one only, physical data model, but whereas here the data type will be there. What is the customer key? Customer key is something like a char type, and here the length of the customer key is 10. So we define the data type and the width of each column, right? So in first name is something like varchar, it's a data type 20. This column can have 20 letters in it. Okay, and similarly, for last name also we create the data type. We define the data type and the width of for the date column in each table. So that is what your physical data model. In the case of physical data model, once you create the physical data model, you send it with your stakeholders, and then you can vet it with them. You can vet it with them. So that means once they review the data model, the physical data model, and if they find any gap, so look here, product key is missing. They will give you feedback. Where is the product key? Guys, please include product key. They'll give feedback in case of any gap. And then after getting the feedback from them, you can validate that. In case you have any valid justification why you did not include a specific column, you can go back and tell them. Okay, but you need to validate it. Whatever the feedback they give it to them is really valid. If it is valid, you go ahead and include it. and then amend your physical data model, and then create the tables in the database. That's all. Once you create the data tables in your data model, you are ready to start creating the reports, because you already define the data model, right? So you define the data model, what are the tables that are required to create the various reports requested by each department or the specific department manager. Okay, and then each table, what columns are required, and how these tables should be linked with each other, with which column, and all these things you define it as part of logical data model. In the case of physical data model, you define everything along with, in addition to this, you will define the width of the data type and width of each column, and then you are going to create the you are going to implement the table in the database. So what is a database? So this is your, let's say, in your SQL server, Microsoft SQL server, it's an RDBMS. It is a relational database management system. What we do is, here we create the database. Let's say the database name is supply chain analytics, something like that. Okay, supply chain. Or what we do is we say, enterprise data warehouse, enterprise data warehouse. So so what they do is they create a database. So an SQL server, SQL server can have one or many databases in it. Okay, you can create as many databases as you want. Let's assume that this is called your enterprise data warehouse. The database name is enterprise data warehouse. Here you have a separate, schema for supply chain. All the supply chain related tables you store it here, or listen, you have something called sales, schema. The sales schema, all these tables, like I said, right, all these things, all these tables, you go and create it under the sales schema. Okay, the schema is nothing but the logical, entity. So each logical entity you store more than one tables in sales in sales database or sales schema. You store all the sales related tables, like I've shown you earlier, right? And all the tables with the data you can store it here. Once the data and the schema is ready, the reporting users as a Power BI developer, what you can do is you can go and pick up the data from here, and then you can create the charts and reports everything. Okay. So now in this, so this is the data modeling process flow. First, we identify the entities. As per the conceptual data model, while discussing with the stakeholders, we understand what are the tables that are required, and identify the key properties of each entity, and identify relationship among entities, and properties in the sense, each table, what column should go, and which column is a primary key column, and how we can link one table to another table. That is what we do it here. And next one is the map attributes to entires completely and visualize the data. So the next step is we implement the tables in database, and then we visualize the data using Power BI, the report canvas. And then, so what we do is finally, right, so visualize the data and then assign keys as needed and determine degrees of normalization. So that is what we do it here itself. Okay. And finally, you go and share it with your customers about your final data model, the physical data model, and vet it with them. If they say, okay, everything is good, go ahead and create the tables in the database. Yes. Usually what we do is, right, whatever the comments they give, we just go and validate it. If it is really valid comment, then we go and implement it. In case of any any conflict, right, we go back and tell them, so this is the reason why we did not keep this column separately, or we did not include this column. If they agree, fine. They still insist you to keep that column, right? So then you go and you need to mentor them some cases, right? Because the business stakeholder, they do not know they don't have the technical knowledge. So they will tell why you need to have two tables, keep combine these two and put it in a single thing. You tell them that is our area. Okay. So first you just confirm from your side, all these columns are really required or not. Which one is primary key? Everything we will take care. Okay. Because you don't know technical thing. Later point into they should not blame us. I'm not a technical guy. You should have explained me, or you could have justified me that time, right? So what we do is they do everything with them, right? So you just talk to them and get it done. And finally, if they say go ahead and implement it, you go and create all the tables in the database. This is the typical data modeling process we follow. So so as part of this, we do some normalization, everything. Okay, I'm going to skip the normalization now. because we are going to look at only about the star schema and snowflake schema, because in the analytics side, from the data analytics point of view, we have something called data warehouse. Okay, and the data warehouse, in the data warehouse, like I said, it's a database. Okay, it's a big database, and for each subject area, like I said, you have sales subject area, or we can say schema. Instead of saying schema, we can say subject area. Sales subject area related all the tables, you store it separately in this, within this data warehouse. You create some kind of logical user ID, something like that. Okay, so you create schema. Okay, and then here you store all the sales. And finance, you create a separate subject area. All the finance related tables, right, you store it here. And all the finance, sales, and supply chain, right, you create separate thing for that. Okay, the data warehouse encompasses all the subject areas in it. Okay, uh, fine. So, but the now the question is, what is the difference between data warehouse and database? See, we data warehouse is an umbrella term. It's a concept. Okay, end of the day, you store all the subject areas, related tables, and data into a database. Okay, we call that a data warehouse because data warehouse is, this database is meant for analytics. This database is meant for analytics, which means in the case of data warehouse, we store the historical data. It depends on the company. Some companies, they store 5 years of data. They capture all the transactions, whether you cancel the product or you modified the product, or whether you ordered a product, right? So they, all these information, what products that you ordered, and when you cancel the order, and which items in an order you made changes, all these information, each and every changes, whatever you made it in your source system, right, that one will be captured here. This will have the historical data, and it is non-volatile. So once you store the historical data, you will not make any changes to the data here. Okay, because let's say you ordered a product yesterday, your order number is 100, and for this, today you are going to cancel it. This happened yesterday. The yesterday will data will be loaded here, and today you cancel, that one also will get loaded along with the some flag it says cancel order, something like that. So C means, oh, the same customer ordered this ordered a product under this order number, and then the same customer, they cancel the order which they raised it yesterday today. Okay, all these records will be maintained here. So, and so that's the reason why we don't, since we capture all these type of transactions, capture the historical data, the volume of the data is very high. Since if you make any changes to it, if you make a simple update in SQL, you have something called update command is available, delete command is there. And if you use any update or delete against this data warehouse, it take a lot of time. It will slow down the performance. Hence, try to avoid update and delete in data warehouse. That's what I said, non-volatile. We are not going to make changes. Rarely we do update, but we don't make frequent updates. Okay, and historical data, it captures 5 years, and also time value. It will capture all the time related data. Okay, so that you can find out, you can perform like for like analysis, like year on year sales comparison. What is uh, August 2022 sales versus what is August 2021 sales? If you want to compare it, you need to have the data with the time-based data, right? So that you can perform time-based analysis. So hence it is a time variant, it is non-volatile, and it is an historical data. Got it? That is what data warehouse is all about. Data warehouse, basically we store all the historical data so that you can perform year on year analysis, quarter on quarter analysis, month on month analysis, everything you can do, even week on week, day on day. You want to, what is the, so what is this week sales, what is the last week sales, you can do it. Okay, so hence it is called as time variant. We store the time based data also here. Now the $1 billion question is, so everything is fine, why data model needs to be done in Power BI desktop? It is all done in the database level itself as part of data warehouse, right? When you create the data warehouse database, and let's say you are going to create a separate schema for sales, or the subject area for sales, you create a separate schema. You store all the tables related to sales. And while you create the tables, you define all the relationship here. Okay, if you are having a data warehouse, if they already create the data model, it is a plain vanilla for you. You don't have to sweat too much. Simply go and import all the tables. Okay, the relationship will also get imported into your Power BI model. For example, you are using the Excel files or flat files like comma separated value files or JSON files. You are using it, right? So in that case, you need to create the data model in your Power BI desktop. And also, not all the companies can afford to have a data warehouse because it's a very expensive one, right? So creating a big data warehouse, it requires a lot of people to develop the ETL thing, everything, right? So some mid-sized company or small companies, they cannot afford to have a data warehouse. So in that case, right, the data will be available in files or something like that. Using Power BI desktop, we need to create the data model. Now the $1 billion question is, why, first of all, why do I need to create a data model? Okay, this has been already done. If somebody has done the data modeling part already in the database, like SQL Server and all, right, your job is pretty simple. Whereas there is you are not using SQL Server. Instead, you are still relying on the flat files, JSON files, or XML files, some cloud-based files, right? Then what you need to combine all the tables, but still you need to do the data model design in your Power BI desktop. So two reasons. One is, if the data model is not already in place, then you need to create it. Whether it's RDBMS or not, you need to create the data model first. Okay, if the data model is already created by somebody else in the database, then it is plain vanilla. Simply go and import it. That's all. You don't have to do any data model design. Number one. Number two is, if the data model is not in place, okay, again, it is a flat file and JSON file. So in that case, you need to create the data model in your Power BI desktop. That is where we need to have something called model view in Power BI desktop. In the model view, we go and create the data. So one beauty is, in Power BI desktop, once you import all the necessary files, it automatically detects the relationship between the tables and it creates a relationship automatically. I'll show you, don't worry. Okay, the next question is, okay, fine, I create the data model in the data model view. Now the question is, why should I create the model? So I imported all the files, then why should I create the relation between the tables? It automatically detects the relationship, fine, but why it is required? But whereas in the case of ClickView, there is a tool called ClickView or TabView. There we don't have to do it explicitly. But when it comes to Power BI, you have to have a data model in place already. If you don't have it, you need to create a data model. Full stop. Okay. If you don't have the data model, the slicing and dicing will not happen. It will not perform the filtering. It will not performing the filtering automatically. What do you mean by filtering? For example, you have a table, like you have a country table and you have a sales table. What is the common column between these two tables? Country ID. Okay. And when you imported these two files, let's say these are Excel files or CSV files imported into Power BI desktop. Since these two columns are common between these two tables and the column names are also identical, it automatically creates a link. It puts a line here. Okay, but if you see here, for each country, the data has been stored only once. For example, United States, only one record is there. There is no duplicate. Australia, only one time it got stored. There is no duplicate. So for each record, or for each country, it will have a unique record. It will not have the duplicates. Whereas if you see at the sales table, obviously it can have duplicate values in the country ID column. In the country ID column, it can have the duplicate values because in US, 4 different times or 5 different customers, they ordered a product, right? It should capture the details of all the transactions along with the country information. In this table, the country ID can have duplicate values. This is one-to-many relation. This is one side. This is many side. In a single country, more than one order can be, found in this table. Okay. And here, if you look at here, okay, the relationship got created. So how the, once the relationship get created, what happens is automatically it does the filtering. How the filtering is happening? For example, what it does is first it goes to the first record, and then it goes and filters the record similar to United States automatically. Look here, these 5 records, 1, 2, 3, 4, 5 records got filtered because these 5 records are related to US. Okay, since we have created the relationship between these two tables with the link, right? It does the filtering automatically. And then what it does is it skips to the next record. For example, you want to find out the total sales we made in United States. It goes and filters the records that are relevant to the first record, and then it applies the sum. So it applies the sum on all these values. So 2,500 plus 1,000, 3,500, 3,750, and 4,110. 4,110. This is the total sales. It applies the sum on only these 4 values, because these 5 values, right? 5 values belongs to US transactions, right? So 400. And the next one is it skips to next record, Australia, and it goes and filters the records that belongs to Australia automatically. Similarly, once it does the filtering, and the next one is it will skip to the next record, and it goes and filters the record that belongs to Germany. So in Germany, right, so you have only one record, and similarly it does the filtering for the rest of the records. Got it? So I just show you a demo in Power BI Desktop, how we can create the relationship. I guess all of you are comfortable so far, right? So please concentrate, put your mobile phone on mute, and I just load the files. For example, all these files are available in my website. And for example, sales fact. Okay, this is not a CSV file, it is an Excel file, I think. So that's what sometimes you might encounter, right? So you might be thinking it's a CSV file, and you'll be go and checking it. Okay, dim type, you just type dim sales is not, dim category is not there. So, okay, it is not a CSV file, it is an Excel file. I just go and see a sales fact. Look here, when I type sales, it is getting this sales fact is not there. And I just say NC sales, has something called NC sales.xlx. I just go ahead and import it. This is my fact table. I'll explain you what is a fact table. Don't worry. Okay. This is kind of like your order table. Okay. This is your, this captures all the transactions made by all the customers in it. Okay. And I just load the data. So you have seen it, just to load, less than 100 records, it takes this much of time. Look here, I just go and expand it to see the columns that are part of this table, NC sales. And I just go and click on this ellipses here, 3 dots. This is called your ellipse. I just click on it and I just go and rename it. Okay, this is, I just give some meaningful name, sales fact. It is important it is mandatory that you need to follow strictly the naming convention. Okay, so they will give you some document once you get into project. They will give you some coding standard and naming convention document. You need to ask them, even if they don't give it, you need to ask them and see what naming convention they followed. Okay, so here I have given sales fact, right? And the columns that belongs to this table, I can see it. If I go and click on the data view, I can see the data that belong to sales fact here. Fine. Okay, all the data are available. Very good. So next, what I do is I just go to the model view. This is called your model view. Okay, anything related to data model design, we do it here. So we can see that sales fact table. Okay, good. Something like a table kind of thing, right? We can visually see that something like a table kind of thing. And next, what I do is I just click on the get data. I'm going to load another file because in the real-time scenario, we'll be working on it many tables, not single file. Okay, most of the time we'll be working with many tables or more than one files. For example, now I just go and say dim product XLS, and I'm going to open it. Okay, I just select dim product. I just take a look at everything is fine. I click on load. So now I loaded in total 2 files. Fourteen rows to load 14 rows. It took this much of time. In this case, I don't have to rename the table or file. It is already, in the proper naming convention. It follows the proper naming convention. Good. So now what you notice here, the moment this one got loaded into Power BI Desktop, the dim product, what did you notice here? So what did you notice here? There is a link between these two tables got created automatically. I did not do anything. I simply loaded these two tables. That's all. But when I go to this model view, when I clicked on this icon, it took me here. When I see here, this link got created automatically. Oh my God, I just pressed it. Let's check it. Well, the link got created. So what does it say? So when you see on the product table side, one here, and when you see on the sales fact side, you can see a star. That means many. So right, so one to many relationship. There exists a one to many relationship. This one was detected automatically by Power BI Desktop. One way we should say thank to Power BI Desktop, right? We don't have to create the link manually, right? It does the automatic link between the tables relationship. Okay, now I wanted to. I'm just curious to know between these two tables, which columns are used to create the relationship, right? So I told you one thing very clearly: to create the relationship between two tables, the common columns will be used. Based on the common columns between the two tables, you need to you need to create the relationship. To validate that, I just keep the cursor over here. I just keep the cursor over here. The moment when I hover the cursor here, automatically on the both side you can see the product ID got highlighted, which means these two tables got created, right? So, the relationship between these two tables are created based on these two columns, product ID and product ID. Since these two tables have a column by the name of product ID is available, it created the link between these two tables automatically. Okay, now the question is, sir, I don't, let's say in the left side, in the sales fact, instead of, let's say in the sales fact table, I have a column called product ID is available. On the right side, in the dim product, instead of product ID, I have some product key. So in that case, it will not detect automatically. The column names are more or less matching, right? Based on the common column. See, the funda is to create the relationship between the two tables, you need to have the common columns in both the tables. Since we have product IDs available in dim product or the product IDs column is available in both the tables, it creates the relationship automatically. Even if you want to create a relationship manually, We have another option to create the relationship between the tables or amongst the tables. Right? So one is automatically it detects. Sometimes manually we have to create the relationship between the tables. So in that case, also you need to check which are there any common columns or exist between the tables. Okay, which common column should I use it to create the relation between the tables? You need to first check that one. Okay, I will just show you now the second approach. The first approach, it created the relationship automatically. Let's say, how to create the manual relationship. I just delete the relationship. How do I delete the relationship? Just keep the cursor on top of this line, right click on it and delete it. Okay, now there is no relationship exists between these two tables. So what I do is, how do I create a relationship? Select either this column here or column here. So I'll let you know, I just drag and drop it on top of this column. This is mandatory. You need to drag this product ID and then drop it on top of this table's product ID column. And now you just go and validate, right? When you hover the cursor here, yes, the relationship got created correctly with these two tables using product ID column. You're not supposed to create product name with product ID because you don't have product name column here. Okay. So any of product ID is the primary key using which only you can uniquely identify the records in a table. Okay. Remember this thing. You got it? So automatic, we don't have to do anything. It creates the relationship automatically. But still, even if it creates the relationship automatically, right? We need to go and validate it. Okay, if it is not getting created automatically, how do I create manually? This is how, just do the drag and drop. Okay, the other option is, yeah, I just go and delete it. The other option is, yeah, you have one more option. Just under the home ribbon, you can see something called manage a relationship. Can you see it here? The manage a relationship. You just click on this thing. It will open a dialog box here, and you click on new. And what you do is you select the tables here. You just click on this one, and you select dim product. Okay, here since we have only two tables, the moment when I selected one table, automatically second table got displayed here. Okay, now you select the product ID in this table, and you select the same column product ID in fact table. It is mandatory. You need to select the common columns. Okay, for example, if I selected a category, look here, you can see that this limit is cardinality many to many, right? So when I click on product ID, so it has one to many relationship. Okay, and this is the manual way of creating it. And also you can see something called cardinality. Cardinality is nothing but the type of relationship. The product table and the sales table has one to many relationship. You remember in the diagram I have shown you just next to the product table one and the fact table I showed you the star, right? There is a one to many relationship. That is what it shows. And you can also change it here. Okay. For example, if it is a not one to many relationship, you can see one to one. Okay. But you don't have to do it. It does it identifies the cardinality automatically. And the next one is you can see cross filter direction. We have two options, or single and both. See, in the previous batch, in the interview, they asked, so what are the options are in cross filter direction? She was literally panicking. Okay, and the other student, she answered correctly. Fat. Okay, the cross filter direction, we have two options, or single and both. Remember that, single, both. Okay, cross filter direction, you have two options. In the case of cardinality, you have one to many, and many to one, and many to many. Very easy to remember this. Right? That's all. Don't don't worry about this at this moment. You will learn everything in the short while in detail. What is? Give me some example. One to many. Everything I'll give you some more examples so that you should be able to understand very clearly. So cardinality is nothing but the type of the relationship. So whether these two tables have one to many relationship or one to one relationship or many to many relationship, that one also detected automatically the moment when you select the common columns between these two tables. How did I select it? For example, I just clicked on the product ID and I clicked on the product ID in this table. The relationship got created automatically. Click on OK. Look here, you can see that from table to table. From dimension product table, the product ID got linked with the sales facts product ID. Now we are all set. Click on close. Look here, it will take some time and then it put the link automatically. And still you can go and validate it. Just keep the hover the cursor on top of this. Hover the cursor in the sense, keep the cursor on top of this slide. Very good, right? It's very simple. Very interesting one. Okay, the next one is I'm going to import another file called dim location. Dim location. Yes, it's an XLS file. I just imported. I just click on a sheet one. You can see that column one. It requires a little bit, data transformation because the column names, I actually it is the column one supposed to be location key, column two supposed to be location name. So it is the column names were not assigned properly. Little bit data transformation is required. So for that, what I'm going to do is I'm going to the Power Query editor, transform data, click on the transform data. So click on the sheet one and you just go to the transform ribbon, use first row as header. See, I want to move this row right to column header. Okay. And you have a, cool option is available. Use first row as headers under. So when I select this option, what will happen? The location key will get shifted here. Location name will get shifted here automatically. Look here. Fine, right? So it got shifted with the respective places. Yes, this column name is location key. And this column name is location name. Everything is fine. I just go and click on file and close and apply in Power Query editor. Now you can find that location table also here, dim location table. Look here, the link got created automatically. This is sheet one, okay, and you just go and rename it with the meaningful name. Click on the rename and then dim location, meaningful name, you can give it dim location. This table is also a dimension table. It's kind of a lookup table. Dimension tables are your lookup table. I'll explain you what is dimension tables a little later. Don't worry. Okay. And okay. So now what happened? We have created the relationship successfully between these two tables. And I just go to the report canvas. You might be curious to see, right? After creating the model, how can I create a report? For example, I just click on this clustered column chart. This is available under the visualizations. When I click on it, automatically this visual get dragged to the report canvas. In the report canvas, the clustered column chart got created with dummy data. Now we need to populate the data into this visual. So that's where we already created the tables and we created a relationship. For example, your manager is asking you, what are the sales in each location? Well, location wise sales performance, I want to say sales by location. You just drag and drop these two things directly into your visual. Look here, location wise sales, you can see it here. So you can see it in Chennai, the sales is more. Delhi, and the second top sales we made in Delhi, and rest of them are okay. Okay, in Bangalore, this is the sales, and Bangalore, why the sales is less? Okay, so this is the visual, right? Okay, you need to understand one thing very clearly. So what columns that I dragged and dropped it here? The sales amount and the location name. This is a text one. Location name is a categorical variable and sales amount is a numeric variable. So you need to have the text and numerical value in the visual. Anyway, I'll explain you in data visualization in detail about this. The thing is, the moment when I dragged and dropped the location name and sales amount, automatically it splitted, right? In each location, how much sales we made, right? It is doing it automatically. The splitting is done or the filtering is happening automatically. Okay, instead of visualizing this as a clustered column chart, I just convert this a different visual. For example, I want to convert this column chart as a matrix visual. How I do that? So we have something called, if you go to the visualization pane, right, just beneath this, you'll find something like matrix. Select this visual, click on matrix. It got converted as a matrix visual. It is that much simple to convert from one type of visual to another type of visual. See, in Power BI desktop, right, we call the charts as visuals. Okay. And matrix is also kind of a visual. We just convert this one. Okay. And location name, sales amount. You can see this one. I just remove the sales amount, just finish it. So you can either drag and drop the columns into the visual directly, or you can drag and drop it under this one. One second. I just close that one. One second. What I do is I just go and remove the sales amount from this section. Okay. Look here. So note this one. You can see here there is a field called values. In this field values, the sales amount, right, got dropped here. And then we have another field called rows. In the rows field, the location name got dropped here. I did not drop it directly here. Instead, I simply dragged and dropped location name and sales amount here. Automatically, it picked up the location name column as rows, and the sales amount as the values. Okay, so fine. So now I just remove the location name. You can see the sales amount. All the locations put together, what is the total sales? It displays that. I just dropped the sales amount only. I removed another column. So now what happens? I just go and drag and drop the location name here. Okay, so you can do it here also. Alternatively, I'm just dropping it here. The moment when I drop the location name, it splitted the total sales amount by the location. In Chennai, what is the total sales you made? In Delhi, what is the total sales? See, earlier, when I simply dragged and dropped only one column sales amount into this visual, it was just displaying the total sales amount, 4,56,000. Along with the numeric column sales amount, when I dragged and dropped this categorical variable or the location name column, text column, based on the values that are available in this column, it did this split up automatically from this total sales amount. This is important point. This is the beauty of Power BI Desktop. How it is happening? Because of the relationship. We created it behind the scene. This relationship. Okay. Now, I have asked this question in the slide, PowerPoint, right? So why data model is required? And why should I create the relationship? For example, if I delete the relationship, how do I delete the relationship? Let's say dim location and sales fact got linked with location key columns. And I just go and delete this one. Before deleting this, I'll just show you one more time. Look here, this is the value. And if I go and delete it, let's see what happens. The link between these two tables got dropped. And if I go and see it, what happens? The total sales value got displayed across the rows against each location name. Does it make any sense? No, right? The filtering is not happening. Since we removed the relationship between the dim location table and then sales fact table, the filtering was not happening. So what do you mean by filtering, guys? Just, one more minute. Okay, I will wrap up this. Don't worry. See, this is what the filtering. Only when you create the relationship, look here, it goes to the first record in this table. So in our case, the location name, location key. And since you have the relationship, it automatically propagates the filter from here to here. So in this table, first it goes this first location, and what are the locations are there, corresponding to this. Okay, filter all. For example, it is Chennai. In our case, Chennai, right? Chennai and Chennai related records will get filtered. And then next it goes to the next record. And sorry, first it goes the Chennai thing. You just think, in our case, we are talking about location, right? So I'm talking about this one. So here, okay, in this table, we have Chennai, Bangalore, all the locations are there, all the city names are there. Let's assume that the first record is a Chennai. It goes and filter all the records that belongs to Chennai. And then what it does is it does the sum for the Chennai, what is the total sales? It applies the sum automatically. And then it goes to the next record. Next record is, this is Bangalore. It filters all the records that belong to, and then it applies the sum on this, all the Bangalore related record sales column. Automatically it is happening because of the relationship. Okay, in our case, the relationship exists between these two tables, right? Since we created the relation between these two, it does the filtering. Supposing you don't have the filter, what will happen? The relationship is not there yet. So then whatever the column values records got selected, it will not propagate to this table. This record related data will not be sent to this table to filter it. So then how the filtering can happen? It will not happen. So that is the problem now. Hope you understood. This is very important concept. Okay. And the relationship between the tables are very much important. Rilesh, you have also asked some question related to table, right? The earlier stage. This is the important thing in remember. For example, I just select location key and location key. I just drag and drop the location key on top, not on the other column. Okay, make sure that you drop the column, this column on this column. Now the relationship, after you create the relationship, whether it's automatic or manual, it is a best practice. Just keep the cursor or hover the cursor on top of this line to make sure that the relationship got created correctly between these tables. That is also very much important. How do you make sure that the relationship got created successfully, correctly? Keep the hover the cursor on top of this line and check in both the tables. In both the tables, location key got highlighted. It's correct. Okay, good. And when I go back here, now if you see here, since I recreated the relationship, now the filtering is happening correctly. This is the one you need to, if you understand this one, the DAX concept also you'll be able to understand. Okay, don't, right? So this is the thing, important thing. So initially we have data like this, and then once I drag and drop the values into the matrix visual, it automatically goes to United States and it does the sum on all the sales values, and then it displays only one record in the matrix US. So all the values put together something. Okay, and the next one is Australia. It will put, see, in total only 4 records will be there in the matrix, but it does the sum automatically for each. So that is what, right? The sales breakdown is happening automatically by location. In Chennai, what is the total sales? Automatically it finds out, right? It does the sum for each and every city. So this filtering is possible because of the underlying table relationship. If you don't have the relationship, it will not do that. And sometimes if you create the wrong relationship between the tables, also it will not it will not do the filtering correctly. Got it? Now you understood the importance of data model. Okay, with this, I'm going to wrap up because this topic is quite new and to all of you. Hence, you need some breathing time. I will share this today's session video and you just take a look at it. And also, I will share this file to you all. Guys, please make sure that you are going to download the files, whatever I share it with then and there. Okay, so that, right, you don't have to disturb me or you don't have to wait for me. For example, see what happened, some students 1 month back, even that batch itself was over, and she was asking me, sir, can you please send me this file? I lost it. So what happened, I did not check that message at all, right? So morning and afternoon I was completely exhausted with so many calls, and suddenly when I look at, so what will happen is, right, you will have to wait. There is a wait time there, right? You have to wait unnecessarily. So whatever files I send it to your WhatsApp, so you know how to connect to WhatsApp from your thing, right? Like this you can connect it. So web.whatsapp.com. So you just do some check it in YouTube how to connect WhatsApp in a browser, so that in your laptop, right, you can go here and download the files. Okay, download the files there. Whatever that I send it, keep all the files in your laptop. Don't postpone it, right? Always be proactive. Okay, keep all the files, store it in a safe place, and don't postpone it. Okay, tomorrow I will do it tomorrow. That is where most of us we fail. Okay, guys, thanks for all your time. You have any questions? I would suggest you better you watch my today's video and come back with questions tomorrow. But tomorrow we are going to discuss about the important concepts. Don't miss out tomorrow's session. And any of next 5 days, you are not going to have session. At least attend tomorrow's session. Watch my videos and start practice it on your own. All these files are also available. What you do is after watching my thing, right? Once you download this file, open it, and then check, what relationship. And you can also double click on this link. And it will open up this one. Okay, and look here in this case location key column from this table got highlighted, and in the sales fact table location key column got highlighted. So it is clearly evident that the relationship got created between dim location sales fact using location key column. Got it? So you can explore it, and then you can try to do the same thing on your own by downloading my files from the GitHub or from my website, and then you can play around with. And don't hesitate to call me in case you have any issues. Some says, sir, I have not yet accessed your website or not yet downloaded. Can you please help me out? I'll help you out, but between 12:30 to 3, I can help you out during weekdays, Monday through Thursday. I'll be very Friday to till Sunday. I'm very busy. Okay. So what you do is, you just note down everything. If you remember everything, you don't have to depend on me. So that is what is expected from the IT industry. All right. Okay. Thanks, guys. See you tomorrow. We will circle back same time tomorrow. Till then,